Okay, this is PreCalculus. Solving trig equations. I have a few examples here. Give all answers on the interval to include 0 to 2 pi. Okay, so what does that mean? That means you include 0, okay, with a solid dot, and then you go over to 2 pi and you exclude it. That's what this interval notation means. This kind of bracket means you include that part, and over here you exclude it. Write expressions that represent all answers to the equation, meaning over here you're going to go from negative infinity to positive infinity. But of course, there's no end to infinity, so you can't include it. So it's open-ended, you see, like that. All right, so they want two answers. They want two solution sets here. They want a solution set between just the unit circle, 0 to 2 pi. That would be the entire unit circle. Okay, because here's 0, and then if you go all the way around, you'd be at 2 pi. So you're starting at 0, you're going around. So anything that falls inside the unit circle, they want one set of answers, and then they want you to expand this to include all the possible answers. So let's get going with the first problem and see how that works out. Number 1 is 2 sine x minus 1 equals 0. Well, we simply move over the 1, try to isolate the sine x. So I get 2 sine x equals plus 1. Divide both sides by 2. I get sine x equals plus 1/2. So the question becomes, at what angle would I be getting returns a 1/2 plus 1/2? Well, recall now that on the unit circle we have the radius is 1. Okay, so if I'm up here somewhere, okay, I'm going to be given a y angle, okay, or a y and x position. The sine of something equals y equals r sine theta, from the fact that sine theta equals y over r. So you multiply the r and then you get y. But r is 1 here, so you're going to get 1 sine y. So simply put, the sine of an angle here is y on the what? Unit circle. Okay, so we have, that's y. So here's the y value, okay? The y value is 1/2. Where on the unit circle is the y value 1/2? So you're looking here on the unit circle, and you're saying, well, I don't see it. Oh, there it is. It's 1/2 at what? So this is 1/2 at pi over 6 or 30-degree angle. So there it is right there. And so I always like to reinforce how to get these, but I don't have the time in this video. I guess I should do it sometime. When you're doing the unit circle, this will be 1, 0. This is 0, 1. Okay, and you start out with, well, this is pretty far along the way here on the x-axis, so that would be the largest number, square root of 3 over 2. This one would be square root of 2 over 2. That one's square root of 1 over 2. Okay, that's not as large x-wise as this point. So then you're going for the y values. This is pretty high up, so you get square root of 3 over 2, square root of 2 over 2, square root of 1 over 2. So you see they just reverse order. So it's like 1, 2, 3, 1, 2, 3. Okay. Okay. So the y value, we get the answer here. That x degree would be 30 degrees, or that x value would be pi over 6. So now the question becomes, wait a minute, are there any other places where y is this value? Yes, there is. If you go across the unit circle, you'd see you have a 1/2 over here at 5 pi over 6. So it's not only that, it's also 5 pi over 6, which is 150 degrees on the unit circle. So 2 places, okay? But these are not separated by like a pi or something. So, well, the first answer to this interval is between 0 and 2 pi. Okay, the answer is the solution set of x such that x equals pi over 6 and x equals 5 pi over 6. There's your solution set for the 0 to 2 pi interval. Okay, when you speak this, you say this is the set of what? Of x such that, you say such that, okay, x equals pi over 6 and or x equals 5 pi over 6. Okay, there's your set. Now, on the infinity interval, minus infinity to plus infinity, we have to see what's going on here. We have the sine function is going from 0 Okay, I'm pretty terrible at drawing here. Okay, going like that. Now, if this is 1 plus 1, and this is minus 1 at 0, okay, we're looking at the plus 1/2. So that would be this line drawn through here, okay, plus 1/2. All right. You're seeing there's a solution here, a solution here, a solution here, a solution here, onward and onward to the positive infinity, all the way to the negative infinity. And this one would be our pi over 6. And this would be our 5 pi over 6. Well, the next place we see this corresponding piece here, would be 2 pi later from pi over 6, okay? And then the next place we'd see this piece here corresponding would be 2 pi later. And it would constantly keep repeating like that. And going backwards from corresponding piece to corresponding point on the curve, we would get, going backwards here, 2 pi, okay, distance, okay, and this guy here would be going backwards 2 pi also, and this would repeat and repeat ad infinitum. So this is what where we're getting into how we have to cover all these solutions that go in a positive direction and in a negative direction. And the way we cover that is by saying the set of x such that x equals pi over 6 plus 2 pi k. All right? And I'll get into that in a second. Comma, x equals 5 pi over 6 plus 2 pi k. Okay, lowercase k, close bracket. Okay, where k equals positive and negative integer. And that's how we handle that. And so this set notation covers all the solutions all the way to positive infinity and to negative infinity of this equation. And this is the solution set from 0 to 2 pi.